Is my audio on? Can you hear me? It is. It's being amplified. Good. All right, then. OK. Well, we shall get started then. And yeah, it's really nice to see such a lot of happy, smiley faces out there. I'm choosing to believe that you all deliberately want to be in this talk, and it's not just that you were so mesmerized by the keynote that you just can't be bothered to get up. And but to be honest with you, I don't care. As long as you're here, that's fine with me. So my name is Steve, and I work at Microsoft, and I'm on the ASP.NET team. And as I'm sure most of you know, ASP.NET is primarily a server-side programming platform. So that is what the majority of people on the team are focused on. But I'm a little bit different. Personally, I spend a lot of my time trying to help improve the difficult lives of poor, struggling front-end web devs who are trying to make sense of a world where they have to use Angular and React and Webpack and all that sort of stuff, and try and put that into a shape that at least gives them some kind of meaning and some kind of hope. And as part of that, as you can probably imagine, an important aspect of it is trying to understand where the web platform is going in the future. What are the new features that are coming out that are going to change the kind of programming that we do on the web, or that are going to take things that used to be really difficult and messy and make them better in some way in the future? And that is what this talk is about. You too are probably somewhat interested to know how web development will change in the future. And if you are, then one of the good places that you can go to get some information about that is the various platform status web pages that each of the browser makers have put up. Here's the one that Mozilla has put up about Firefox, and that's got a long, long, long list of all the different features that they're working on and will be putting into Firefox, with lots of information about what versions it's going to ship in and what the status is at the moment. It's not just Mozilla. Here's Google's one that they've put up for Chrome, and that's really helpful. It tells you exactly what versions each of their different features are going to ship in. It tells you also about what level of consensus has been reached among all the other browser makers about each of the different features, and it links to the original specifications so you can learn more about what in detail the APIs are going to look like and so on. Finally, not surprisingly, Microsoft also has got one for the Edge platform. For example, here it's showing you that there's going to be a forthcoming ambient light sensor API, which means you'll be able to detect if your visitors are in a light room or a dark room. I can't imagine what you're going to do with that. Maybe you're going to have some sort of special night mode on your website or something. I don't know. But it's great to know that that stuff is there, and you'll soon be able to use it. Now, if you want to go a step deeper below this stuff to the original standards bodies and the specifications that they're putting out, then there are a couple of different ones there. Probably one of the main ones is the Web Hypertext whatever it says there, the WhatWG, okay? And they've got all of their specs that they're working on listed there, and you can get into that in as much detail as you possibly want. But it can be a bit overwhelming, because if you look at it, there's like 900 different specifications that are being worked on at the moment that are at different levels of completeness. And how do you even figure out which ones of those are going to be interesting and relevant to you in your development life? Well, the good news is you don't have to, because I've done that for you. That's what this talk is about. We are going to spend the next 55 minutes going through 4 major feature areas that are coming to the web, which I think are particularly influential, that are going to change the way that you write your code. Or at least the first 2, certainly. The second 2 are a little bit more less known. The first 2 you've probably heard of already. I'm sure you will have, actually. But hopefully I'll be able to show them to you in a little bit more detail than you've seen before. OK, so the first one, which I think you'll have heard of but maybe aren't quite using yet, service workers. Hands up if you're using service workers in your production application right now. Like 4 people. OK, 5. Right, so not surprisingly, it's a bit early days for service workers because it's only just started rolling out to be on by default in major browsers. But for those of you who are not using it yet, what is the idea with this? Well, the idea is to change how your code can run. Because since the very beginning of programming on the web, you've been subject to a very strict limitation that your JavaScript code can only run while the user is on your web page. As soon as they navigate away, we just tear down your entire application, and that's it. You can't run any more code. But Service Workers changes that. It allows you to register some JavaScript with the browser so that the browser can execute it even when the user is not on your page. And as for why you would want to do that, well, that gives rise to a whole bunch of different features and use cases that didn't exist before. And the most well-known of them is to enable offline support for your application, but there's some other stuff as well that I will mention in a minute. But before we get to any of the other things, let's just start by having a look at what it looks like to write a bit of service worker code. So I'm going to do a demo now. Let's switch over. OK, so actually, let me show you this thing running in a browser first. What I've done is I've created this very, very simple, plain HTML web page that looks a bit like a news feed. So you could think of it as being a bit like Twitter or something like that. But it doesn't necessarily have to be a social media type thing. It could be, say, a feed of deliveries that your company's delivery drivers need to do. It could be a list of bugs that you've fixed or something like that. It's just some source of information that you need to push out to people. And we're going to make this work nicely using service workers. Now, at the moment, this application does not work offline. And to prove that to you, I'm going to go into here, and I'm going to change my browser to simulate being offline. And then when I hit reload, what will we get? We'll get, there is no internet connection. All right, so it doesn't work. It's dead. That's just not a good thing. So let's go back to online, and we're going to try and make this thing work offline, and we're going to do it using service workers. So let's see how the code for that might go. Right, in my application so far, which, by the way, is just pure HTML, CSS, and JavaScript, there's no server-side stuff going on here, I've got this JavaScript file. And as you can see, it doesn't yet do anything. But the first thing I want to do is register a service worker with the browser. So to do that, I can use a little bit of code like this. Now, the only bit here that's strictly necessary is this. I'm saying, browser, using the service worker APIs, I want to register a service worker at this URL. Because the service worker is a JavaScript file. That's all it is. The browser will fetch that, and it will register it. This other stuff here just gives us some feedback about whether it succeeded or failed, but we don't strictly need that. Now, what is in this service worker.js file? Well, it's this. What you need to understand about service workers is that the only thing they can do is respond to events. You can't choose when your service worker runs. If you could abuse it in all kinds of ways and just be mining Bitcoin in the background forever or something. But to prevent that sort of thing, the service worker will only allow your code to run when the browser wants it to run, and it does that by raising an event. And in this case, I am responding to the install event. You can probably guess that that fires when the service worker is first installed. And I'm logging this message. I'll just clean that up slightly. And what's the other stuff then? This thing down here, slightly weird-looking APIs, but basically there are various ways of telling the browser when your service worker is ready to run. And this line here is just saying, I'm ready right now. Don't wait for anything else. And this thing here, as I'm sure you can guess, is a way of loading one JavaScript file into another. Normally, you load JavaScript files using script tags, but we can't use script tags in service workers because, guess what? There are no tags. There's no page. There's no document. This JavaScript is running outside the context of any particular page, so there has to be this other API for loading JavaScript. OK, so let's see if this works, shall we? We'll see if it logs stuff to the console to say that it got installed. So if I do a reload now, we'll see the page gets a success result from that service worker register call, and then the service worker has its install event fired. The install event only fires once. So if I hit reload again, you'll see the page registers it again because it's coded to do that every time. But the browser will fetch the service worker and go, hang on, I've seen this before. That's not changed. I'm not going to bother installing it a second time. So however many times we reload, it won't install again until we change the source code. So let's make a very small change to the source code there, come back and reload. And now the browser will say, oh, look, I see that that's different from before, so I'm going to reinstall it now. But again, it will only do that once, so we won't see in the install event a second time. OK, so that is the install event. There are other events that you can respond to as well. And one of the good, simplest places to start is with the fetch event. Fetch runs whenever the browser wants to request something from your domain, whenever it's going to do an HTTP request. And here, I'm just going to log a message, and you can ignore the rest of the stuff for now. Let's see if this works, shall we? I'll see if it's going to log a message every time we make a request to the site. I'll hit reload, and oh, it seems to not be working, but it is working, really. On the first request, all it's done is it's installed the updated service worker. But when I load it again, now you'll see it's running my fetch event for every single HTTP request that it makes to the domain. The point of that is not just for logging stuff, but so that you can programmatically control what the browser does with the network. I'll give you a very simple example. Let's say that I want to say, every time that we try to make a request for a PNG file, instead of fetching whatever file it was going to be, instead we're going to fetch a picture of a face, and we'll pretend that that was the response from the web server. So now, I'll come back, I'll reload, and the first time it installs the updated service worker, and when I reload again, then we get this picture of a face instead of any of the images, which is great because it's a really fun way of pranking your coworkers. For example, now you'll see that every single time my browser tries to fetch this BBC URL there, it comes back with this face, even though that's nothing like what the web server would normally respond with. So great for tricking people. But that's not the only use case. There are other use cases as well. And like I said, probably the best known one is to enable offline support. And that is what I will show you right now. So let's get rid of this silly code here and make sure that our web page has gone back to behaving normally. OK, good. And I want to change a little bit about how my service worker gets registered. I'm going to start by doing a very simplistic and naive approach to offline support, and then we'll make it a little bit cleverer in a moment. So here is my very simplistic starting point. I'm going to say whenever this service worker gets installed, we're going to define this array, which is a long, long, long list of hard-coded resources that I want to fetch and make available offline. Okay, so I've got this long list, and then I'm going to fetch them and cache them. And I'll do that using this new API called caches. First, I'll delete any existing cache with this name. Then I will create a new empty cache with that name. And then I will fetch all of those hard-coded things and add them into this cache. And when that's all done, I'll say to the browser, right, I'm done, I'm ready now. Okay, so having done that, we can change what the browser does when it wants to fetch stuff for real. We can say, OK, we no longer need to fetch stuff from the internet. Instead, we can just assume that everything that you ever want to fetch is already inside one of our caches, so we can just populate the response directly from that cache. Let's see if this works, shall we? So let's go back, we'll reload. Again, the first time it installs the updated service worker. And now when I reload, it all just seems to be behaving as normal, but it is a bit different because if we look in the network tab, you can see that all these responses have been resolved not using the internet, but rather using the service worker, which means that we no longer need the network at all. And if I put my browser into offline mode, like so, then when I hit reload, instead of there is no internet connection, I'll just get my web page. It just shows up as normal. So my page now is completely indifferent to whether you've got a network connection or not, because it's not going to use it even if you do. All right? So that's fine, but that's too simplistic, really. This is going to lead to problems. What problems? Well, this is supposed to be a news feed, isn't it? What happens when there's a new news item? Let's have a go at putting one in, shall we? I'm going to create a new news item. Let's say it's CNBC, and we'll go breaking Bitcoin down by 99%. OK, and then we'll come back into the browser, and I'll hit reload. Do I get the updated news story? No, I don't. Well, firstly, that's not surprising because I'm offline. So let's go back online and reload again. Do I get the updated news story? No, I don't. What about if I load again? No, I still don't. Why not? Well, because I'm not even talking to the internet anymore. I'm just returning everything from the cache that I've already got. So we've got no way of knowing that there's any new data. So let's make our logic a little bit smarter, even though it's still not super great. We'll have an updated strategy, which is we'll say, OK, we'll try to request it from the internet with that there. And if that succeeds, then we'll return the response that we got from the network. But if it fails, then we'll fall back on returning stuff from the cache. So that's fractionally smarter. Let's see if that works. So I'll load, and the first time it's updating the service worker, and then I load again, and we get the updated news story. Good. So that's an improvement now. And of course, if I was offline, then it would fall back on serving stuff from the cache instead of going to the internet. So that's good. But it's still a bit too simplistic, because the idea that someone is either offline or online, well, it's not really a Boolean state. You're not just online. There's more a question of how online are you? How good is your internet connection? What if you are online, but your internet connection is so slow that the entire universe will have reached its heat death before we finish responding to the network request? That's a pretty bad scenario. And in fact, I can simulate that exact scenario quite easily by pretending that I've got plain Wi-Fi connection, okay? So how is the user experience going to be now? I'm going to do a Control-Shift-R to force it to fetch everything from the network now, and we'll see how long it takes. So it's not going to quite take till the heat death of the universe, but it will take a while, and you can see we're still loading, and we're waiting for these pictures. We're waiting, and here they come. Come on, pictures, come on, come on. Okay, finally, it's done it. Right, so it's not a great user experience right now. It's too slow, even though we were online. So let's make our logic a little bit smarter still. We'll say now, we'll try to use the network, but if it's too slow, then we'll give up, and we'll use the cached data, okay? So here's my third version of my offline support logic, which looks like a lot of code, but it's not too bad, really. What we're doing is we're saying, OK, we'll start by trying to fetch stuff from the network. And if that succeeds, then we will just return the response from the network. If it takes longer than 200 milliseconds, because that's how long my patience lasts, then we're going to give up. We've got 1/5 of a second. If it doesn't finish in that time, then we're going to return stuff from the cache. But we're still going to let our requests continue in the background. Even if we've given up and served from the cache, we'll still allow the request to continue in the background. And when it eventually finishes, we will update the existing cached content. So the user will eventually get updated data. Right, let's see if this works, shall we? First, I'm just going to unthrottle things while we get the updated service worker. Okay, then I will go back to being on the plain Wi-Fi, like that. And I'm going to hit reload. And this time, instead of taking ages, it should come up in 200 milliseconds. And it does. And if you want to actually see the numbers here, let's reload again. You'll see that all of these responses are coming back in slightly over 200 milliseconds, because we were waiting that long to see if the network would respond, and then we gave up and we returned it from the cache. And so now, if there's some new content, let's say breaking, I don't know, Coinbase, CEO happy, Bitcoin up by 99%, okay? Right, we'll go back and we will hit reload, and this time it will complete in 200 milliseconds. We did not get the updated data from the network fast enough, so we haven't shown it, but in the background, you'll see it was updating all the state. So when the user hits reloaded again later, now they will get the updated news story, and they never had to wait too long for it. Okay, right, so what on earth was the point of me showing you all this stuff? The point was not to say that this in particular is the right way to do offline access or anything. The point of it is just to demonstrate to you Service Worker APIs and the fact that Service Worker allows you to programmatically control things that you couldn't control before, like how the browser is going to interact with the network. You can set your own policies for what should be cached and for how long you're willing to wait for network responses, and what you're going to do if things time out. All that kind of stuff is under your control in a way that it wouldn't have been before, and you can apply that logic not just to requests that are running while your page is already loaded, but to the very first request to your page, even before your page is loaded. So Service Worker gives rise to that option, but other things as well. I'm not going to demonstrate it to you, but Service Workers allows you to say what should happen if the user tries to send, for example, save some changes to something they've made while they were offline. We can hold that request in memory and send it later to the browser, even if they're not on your web page at that point. Similarly, we can receive push notifications from your server, even if the user's not on your web page. And a new thing that's just been creeping into the specs in the last couple of months is the ability to do large uploads and downloads in the background in such a way that even if the user closes their browser and then reopens it later, it will resume the upload or download in the background, even though they're not on your web page. And eventually, when it completes, it will send an event to your service worker. Okay? So that is Service Workers. As for browser support on Service Workers right now, it's looking pretty decent. It's already shipped and on by default in Chrome and Firefox. It's also fully implemented in Edge, although it is behind a feature flag at the moment, so you have to go into the settings to turn that on. Hopefully that will be on by default fairly soon. And then as for Safari, Apple has said that, they're developing this. This is something they're going to support, so this is going to be a universal feature fairly soon. All right, that's Service Workers. Let's move on to the next thing now. The next thing is another thing that I know for sure you're going to have heard of, but again, I'm hoping that I can show you a little bit more of the internals of it than you've seen before, and some cool things, and that is WebAssembly. WebAssembly is a pretty big deal in the world of web programming because for the first time since, anybody's memory, it gives us an entirely new way of writing code for a web browser. It's a new code format. It's a binary bytecode format, which is designed primarily around performance. So it's very compact over the network. It's very fast for browsers to decode it and to verify that it's going to be safe to execute. And it's also very fast for browsers to generate optimized machine code just in time when they see that so that they can execute it very quickly. And the idea is, of course, not that you write that bytecode by hand. You can if you want, but that would be mad. The more likely scenario is that you're going to compile to it from some other language. And not JavaScript or JavaScript-related languages, but other things that you would never have used to program the web before, like C or Go or something else like that. So let me show you a little bit of how that might work. I want to run some code on the web that I would never normally be able to run, and it is going to be written in C. Who's ever written some C? Oh, that's a good number. That's like a third of you. Okay, so C is a very venerable programming language that goes back a long, long time, and you don't normally use it on the web. Here's a simple example of printing out the Fibonacci sequence. Fibonacci is a sequence of numbers that's defined mathematically. It doesn't really matter what the sequence is. I'm just using it as an example of some arbitrary code here. And this block of code here, all that does is it reads an argument that comes in on the command line, and then it calls this function print Fibonacci. And if we look up here, here's print Fibonacci, and it's going to just iterate through printing out each of the terms one by one. Okay? Now, if we want to run that code, traditionally, we would compile it to a native binary using a C compiler, for example, the GNU C compiler. I could say GCC, compile Fibonacci.c and produce a native binary called Fibonacci. And then I can run that, Fibonacci, and it says, how many terms do you want? And I'll say, give me 8 terms. And it's going to print out 8 terms of the Fibonacci sequence. Very good. But can we run it on the browser via WebAssembly? Of course we can, otherwise I wouldn't be wasting your time by showing you this. So to do that, we don't use GCC, we can use EMCC, the Emscripten C compiler. And that's going to take mostly the same parameters. We'll compile the same file. We'll tell it that we want it to produce a WebAssembly binary as its output, and it's also going to need to wrap that in a JavaScript file, which I'll show you in a second. So that compiles now, and what that has just generated is these 2 files here. We've got the WebAssembly file, that's the binary, 50 kilobytes, and we've got this JavaScript wrapper file, which is just under 100 kilobytes, and that knows how to load up and execute the WebAssembly stuff. Now, you might be a little bit shocked and appalled that we've got 150 kilobytes worth of stuff come out of there for a 26-line C program, but it's not that bad, really. It really isn't, because something like 99% of the size of those binaries there is the C runtime that's being bundled by default. So even if you wrote a much larger application, the final compile size wouldn't necessarily be that much larger. Also, this is completely unoptimized and uncompressed, so it's really much, much smaller than this by the time it actually gets sent to your browser. But anyway, does it work? Let's try and run it, shall we? And to run it, we're going to need to have an HTML page that we can load in a browser, and I've got one right here. I know it doesn't look much like HTML, but technically it sort of works. And I've got a script tag, and it's going to load this JavaScript file. And up here, there's rather odd syntax for specifying what arguments should be passed to it. Okay? So let me try running that now. I will launch that in a browser with Control F5 there. And when that pops up, let's look in the console, and we will see that it is indeed printing out the first 10 terms of the Fibonacci sequence there. Okay, good. So it does actually work. Can we see some of the internals? Can we see the code? Well, we sort of can. Yeah, so this is sort of the code. It's a bit hard to make sense of. If we want it to be a bit easier to make sense of, we can compile it with this G flag, which produces a nice debug build there. And if I've done that, then when I come back and I hit reload, you'll see there's a new thing that showed up down here, and that is the original C source code, because it's now produced source maps. So that's sort of nice, but it's still of limited usefulness because things like breakpoints and such don't really work properly yet, although hopefully they will do at some point in the future. But still, can we get a bit more insight into what's going on inside this? Well, another thing that got generated when I did that debug build there is this WAST file, WebAssembly text, all right? And that is a text representation of the same stuff that is in the binary WASM file. And this is designed to be human readable, although obviously it somewhat depends on what kind of human you are as to whether you can read that. But I think we're the right kind of humans. We can do this. Okay, so we want to try and make sense of where is print Fibonacci in all this giant pile of stuff. So I'm going to search for print Fibonacci, and there it is. Okay, that looks interesting. It's still a little bit hard to make sense of, but we can make sense of it because, look, we've got line numbers. And we can see that that stuff there is what corresponds to line 5 in our C code. All right, what is line 5? This is line 5. I'm declaring two locals. One has got a value 0, the other's got a value 1. Okay, and here we're declaring two locals. One of them's got a value 0, and the other's got a value 1. So we can somewhat see the correspondence. And the same in other cases as well, like here's line 11. This is where we're adding two things together. And if we look for the stuff that corresponds to line 11, it's all this stuff. And in the middle of there, you can see that there's an integer add operation that operates on two locals. So we can kind of make sense of this a little bit. You wouldn't want to write this by hand, but you can see what it is now. It's a stack-based virtual machine. If you've ever seen MSIL, the bytecode that underlies .NET, you'll recognize this as being quite familiar, because although it's not the same thing, it's a similar sort of programming environment. Okay, so it does similar kind of things in a similar kind of way. Okay, so that is WebAssembly. And like I said, there's lots of work being done on being able to compile to WebAssembly from lots of different types of languages, particularly those based on the Clang toolchain, so Go and Rust and Swift, those kinds of things. They're doing a good job of making it possible to compile to WebAssembly. And this got me thinking, wouldn't it be really cool if you could run .NET on WebAssembly as well? That would be awesome. What would we need? Well, all we would really need would be a .NET runtime that is itself written in C, and then I could compile that using EMCC to make WebAssembly, and then I could run the WebAssembly in my browser, and I could load .NET assemblers into the browser, and it should all just work, shouldn't it? Shouldn't it? So I went looking to find a .NET runtime written in C, and guess what? There is one, and I'm going to show you right now. Okay, so this is what I found on GitHub. A lot of C source code, all right? So this is about 98 C files, and it deals with stuff like, what is it, generics, heap, finalizer, JIT. They all sound very .NET-y, don't they? And that's because this is a .NET runtime. Now, it's not the .NET runtime. It's not .NET Framework. It's not Core CLR. It is a runtime called DNA, which is written by Mr. Chris Bacon, who's sitting in the front row here. I was very excited to meet him just a few minutes ago. And it's quite amazing that he single-handedly put together an entire C runtime that actually works. Now, he did kind of abandon it 6 years ago, but still, it's pretty awesome that it's still here and it works, and we can now compile it and then run whatever .NET code we want. You can compile it to regular native code, or you can compile it to WebAssembly. So that's what I've done. So let me show you. I'll go to WASM DNA, and we will look at the contents of what got generated when I compiled this. And we got these two files, okay? So just like before, we've got a WebAssembly binary file, which is 150K. We've got the a JavaScript wrapper, which is about 200K. So altogether, we've got about 350 kilobytes of stuff there. But again, this is very uncompressed, unoptimized. In practice, it's a lot smaller when it gets into the browser, as I'll show you in a second. But again, does it actually work? Let's try. So if we want to run this stuff, again, we're going to need a web page to host that in. And here is the web page for that. So I've got a script tag here, which is going to load dna.javascript. And I'm going to need to pass some arguments to it in some way, but I don't really know what that is yet. So let's figure that out in a minute. Firstly, let's run this thing, shall we? So let's start an HTTP server in this directory here. And then I can go to the port that that's listening on, and we will see if it actually manages to run the DNA runtime. And we can see it does look. It is actually executing DNA. And DNA says, all right, fine, tell me what .NET assembly you want me to execute. So we better do that, haven't we? What .NET assembly can we use? Well, I've got everyone's favorite, the beloved console app 1, right? And what does console app 1 do? We all know this. It prints out hello world to the console. All right, so I can compile that now. I'm just going to run build, and that's going to generate a .NET DLL on disk. And then I want to pass that as a parameter into DNA. Okay, so here are the options I need to pass. I need to say, I want you to run console app1.dll. Oh, but by the way, you can't really read files from my disk. You're running in a web browser. So I need to configure what you're going to do when you try to access a file system. And I'll say, when you try to access this file, console app1, you're going to need to actually fetch it from this URL. And similarly, in order for this stuff to work, you're going to need the core library that contains implementations of string and a list and all the other .NET-y stuff. And that's going to be in this file, which has got this URL here. Okay, let's try it then. So I'll come over here and I'll hit reload, and then this time it actually loads and executes the .NET assembly directly in the browser there. And to prove that this is really working and doing the actual thing that we think it should do, I will put in some extra C# code. For example, I'll put in this print Fibonacci implemented in C#. And then I can run that from up here. Let's have print Fibonacci, and we'll have the first 12 terms, let's say. I'll do Control F6 to rebuild, which only takes a second, and I'll do Control R to reload, and we'll see now it's running our updated code right there in the browser, which is pretty super, yeah? All right, thank you. Most of that credit goes to Chris down here, because I did like 1 hour of work to make that happen. Okay, so that's WebAssembly, and now, like I said, the DNA runtime is not itself under active development, but since we started messing around with this, the Mono team has publicly committed to bringing Mono to WebAssembly. So you will not have to use DNA. You will be able to use a fully supported, up-to-date, very efficient and feature-complete runtime, Mono, actually inside the browser. And so given that sort of prospect, you might be thinking a little bit like I did, hey, wouldn't it be cool if there was like some sort of framework that you could use to build client-side web applications in .NET so that I could do my back-end in C#, I could do the front-end in C#, and I wouldn't have to deal with like 400 different JavaScript libraries and Webpack and all that kind of stuff? Wouldn't that be some sort of magnificent utopia? So I had a little go at that, and I want to show you some of that stuff now. But before I show you, I want to caution you that this is experimental. This is not something that anyone is promising to ship as a supported product. This is something that we've been messing around with and playing it and trying to test out whether it would produce a good result and whether people actually want it. So I would like it if as many of you as possible would give us some feedback about whether you want this sort of thing, and if so, how it would need to work for you, what kind of constraints you would see on it, and basically what you want out of us. And you can go and try it yourself if you go to GitHub and download the stuff from this repo. But let me actually show it to you right now. So I'm going to go into Visual Studio, and I'm going to create a new project using this experimental framework. So I'm going to create a new Blazor application. Blazor is Browser plus Razor, and I'm going to call it NDC London. There we go. And I will create my new application there. So that's obviously going to set up the initial file structure for me on disk, and it's going to deal with restoring all the packages and such that I need for this thing to actually run. Now, I'll show you the code in a second, but first let's just start it up, and we will make it run in a browser, and we'll see what kind of functionality we will have and what it can do. And here it comes. Takes a moment the first time because it's still compiling stuff, and there we go. All right, so we've got a client-side single-page application. It's got the sort of features that you would normally expect, like it's got front and back navigation. It's got an example of a button that you can click, and it counts how many times you've clicked it. And it's got an example of fetching some data from an endpoint on the server and rendering it in a table. Now, the implementation of that is not the same as what you might normally do, because normally you would build this sort of thing with a JavaScript library like Angular or React or Vue or something else like that. But in this case, there is no JavaScript whatsoever. All I've got in my project here is CSS, HTML, and then C# stuff. Now, the C# stuff comes in two different flavors. We've got regular C# files, CS files, such as this one that's dealing with starting the application up. But we've also got some Razor pages. I know a lot of you here have used ASP.NET, so you will probably know what Razor is, but it's a syntax for combining C# with HTML in a very clean way that gives you really good tooling support. And this is the implementation of the counter that I just showed you. So the counter looks like this. It counts how many times I click a button. And the implementation is we have an int that counts how many times you've clicked. We use Razor syntax to display that in the UI, and we've got a button, and when you click it, it's going to increment the count by calling this method and incrementing that. And that's really all there is to do it. So it's very, very straightforward. Okay, but is this really practical? Is this going to deliver a good application building experience, and can we actually build some useful and interesting functionality with this? Let's try it out, shall we? So, as a very important matter of professional ethics, I must demonstrate this to you in the form of a to-do list. As you know, that's a legal requirement, so I'm going to do that right now. I'm going to move my IDE down here a little bit so that we can see both the browser and the IDE at the same time. And I want to start by adding a new item into this list for to-do list. All right, so I'm going to find the nav menu component, and I'm going to scroll down, and I'm going to copy one of these list items there, paste another copy in it, and I will say this points to a URL to-do list, like that. And I'm going to set the text on it to to-do list, and I'll hit Control-S in the browser, and as I do, you see that the web page is updated automatically in the background, so we've got to-do list there now. And if I click on to-do list, what happens? Well, nothing happens. Well, actually, something did happen. You see the URL is updated, but it doesn't know what to render because we don't have a component called to-do list, so it's not really doing anything else just yet. So let's create a new thing in here. I'll do add new item, and I will call it to-do list. I know the text is too small for you to read there, but it doesn't matter. It's called to-do list, and there we go. The browser is updated again, so now there is a to-do list, but it's blank by default. Let's start by putting some content in there, shall we? So let's put h1 to-do list with better spelling. There we go. All right, so we've got our heading there. Nice. And I want to actually start modeling a to-do list now. And since I'm going to do this in C#, I will have a functions block where I can put some arbitrary C# source by the C# source code. And I will have a class initially, and I will call it to-do list. And I'm going to give that a couple of properties, prop string text. Okay, so each to-do item is going to actually to-do item. Each to-do item is going to have two properties. We'll have a string called text, and we'll have a bool called isDone. Make sense? Yeah? All right. But we don't just want to have one to-do item. We want to have a whole list of them. So I'm going to define a list of to-do items, and we'll make that as a new list. Very good. Now, what can we do with that? Well, let's start by displaying how many items are in the list. And I can do that with some Razor syntax. I'll do to-do items.count. And we will save that and see initially there are 0 items in that list, like you might expect. And I want to actually represent that on the UI in some HTML. So I'm going to have an unordered list, and I'll say for each var item in to-do items, I want to render a list item, and each one will display the item text. Save. And we still don't see anything because, of course, this list is empty, so there's nothing to show. I better add a button on there, button, I'll call it add item, and when I click on that, nothing happens because I haven't wired up any behavior to that now. So how can we respond when the user clicks? Well, if we were writing some very old school JavaScript, we could do this. We could write onClick, and then we could start writing our JavaScript out in there. But because this is Blazor, I can write some C# code to handle the event if I want to. I'm going to change this in a minute, but for now, what I want to do is I'm going to say to-do items, add a new to-do item, and we will set the text on the new item to whatever. All right, hit save on that. And now, when I click on this button, you'll see it is adding items to the list, and it's updating the count, and everything looks good, and we're feeling happy. Okay, but this is not really great yet because, firstly, I don't want to hard-code this word whatever. That's not hugely useful. But also, I really don't like having a big chunk of C# code in the middle of an HTML attribute. That's kind of disturbing. So instead of that, I'm going to have a method, and I'll call it addItem. Okay? And inside there, I'm going to take the code that I had before, like this, and I'll paste that in there. And then, as a sort of convenient shorthand way of calling that, I'm going to say onClick, and we'll pass the add item to it. And this is the benefit of giving you nice type checking to make sure that any parameters that your method takes correctly correspond to the right sort of event that you're handling, that sort of thing. Okay, let's just check this still works. Yeah, it does still work, that's good. But I want to remove this word whatever. I want the user to be typing in whatever it is that they want to add. So I'll have an input, and I'll put a placeholder on that to say type here, type here. All right. So we've got our text box there, but it's still ignoring us. We're going to have to capture whatever it is that the user has typed in there, and I'm going to capture that as a string, and I'll call that next item, like that. And then I can bind the value of this text box to that variable next item. So whatever is typed in that text box, it's in this string next item, and then, oh, that's nice. This is not finished yet, as you can see. So we'll remove this hard-coded whatever, and we'll put next item in there. And I automatically want to clear that text box out as well. So I'm going to set the next item back to null. And that's going to make the text box go blank after the user has clicked it. So now I can type in first, and it goes there, second, and it goes in, and things are working. That's great. Okay, but what else do I need to do? Well, I need to make this editable, and I need some way of actually marking items as done. So let's change this a little bit, and we'll have an input that is bound to item.text so that you can edit the text if you want to. And I'll also have an input of type checkbox, and I will bind that to the item is done property. Very good. So now, if I add stuff, you'll see that it's got these checkboxes, but we can't really see that the checkboxes are doing anything yet. So just so that you can see that actually works, I'll change what we count. Instead of counting all the item, we'll just count the incomplete items. And we can get the number of incomplete items by doing a link query to say, give me the count of all the ones where the is done property is still false. Okay? So now, when I add some things, you'll see we've got 3 incomplete items, but as I check these boxes, the count is updating in the way that you would require it to do so. Okay, very good. So we have just built ourselves a simple but somewhat functional to-do list component in, 31 lines of fairly straightforward C# code that I hope you'll agree is reasonably easy to understand. So that's nice. Okay. Thank you. Okay, so nice that you're clapping, but I bet you some of you are thinking, hang on a minute, this is not going to work, this is going to be a disaster. I can think of all kinds of terrible things that are going to happen here. Firstly, you're shipping an entire .NET runtime inside a web page. Are you mad? What is it going to be, like 200 megabytes for a web page? Well, let's find out, shall we? Let's see how big this entire thing is right now. If I'll do a Control-Shift-R full reload, we'll see that this entire thing right now 341 kilobytes, and that's including the runtime, that's including all of the libraries, that's including the CSS for Bootstrap and stuff. So that's a very reasonable size, and that's not even a production-optimized build yet. So that compares quite favorably to some other single-page application frameworks. So that's nice, all right? Now, I know some other people in the room are probably thinking, yeah, that's all very well, if you can rely on people having WebAssembly, whereas I have to support browsers that go back to like the Stone Age, and they do not have WebAssembly, and they are never going to, so this is no good for me. Well, let's see what happens, shall we, if I try to use a web browser that does not have WebAssembly support. Our old friend, Internet Explorer 11. It's never heard of WebAssembly, probably never will. Let's see what happens if we go to this to-do list page inside IE 11. Well, it appears. That's surprising, isn't it? But does it actually work? Let's see. Well, it does actually work. It works completely, and we've got exactly the same behavior. So how is this? We've got a WebAssembly application running inside a browser that doesn't even know what WebAssembly is. The way that is possible is because WebAssembly is a very cool technology, and it's designed to be easily polyfillable for older browsers. In fact, what's happening here is when we compile DNA, we're compiling both a WebAssembly version of it and an ASM.js, which is pure JavaScript version of it. And we're detecting on the fly whether your browser supports WebAssembly. If so, you get the fast, compact version. And if it doesn't, then we load the somewhat slower, larger JavaScript version of it. But you, the developer, don't need to really care about that. It's just going to work whether or not the browser supports WebAssembly. Okay, so that's good. And yet, I'm sure some more of you are thinking, yeah, okay, that sounds all right, but what about debugging? You're not going to make that work, are you? Because you can't connect Visual Studio to your web browser. You're never going to be able to see what this code is doing on the inside. And that did stump us for quite a while. We did not know what to do about that. But then we got some of the cool people on the ASP.NET team to do a hackathon to see if they could figure out how to add debugging support, and they did. So let me show you how that might look. And I'm going to do that by switching over to a slightly different sample here. This is a different Blazor sample that's designed to show how it could be embedded into an ASP.NET application that does some other cool things like server-side pre-rendering and stuff like that. But I'm not going to show you that. I'm going to show you debugging. And so when that comes up, you'll see it looks initially more or less the same as before because it's based on the same template. Again, it's got a counter. It also shows how we can like interact with third-party JavaScript libraries and stuff. But anyway, here's the counter. And I want to debug this. So I'm going to press a special key combination, Control-Shift-D, that you just have to know about. And when I do that, you'll see a Chrome debug window appears. And let's just move that over there. And you will see that it looks like a normal Chrome debugging window, and it does all the same things that they normally do. For example, I can do the element inspector, I've got the console, I can go and look at the source code for my CSS and edit it and all that kind of stuff. But what's different and interesting in this case is we've also got a list of the .NET assemblies that are loaded in the page. And if we expand them, we can even see our original C# source code, such as this here. And it's not just CS files, but also CSHTML files. So here, for example, is the counter page. And I can see my code in that. And I can even set breakpoints on it. So if I've got some breakpoints there and I click over here, you'll see it's paused in debugger, and I've got the breakpoint over there, and I can now resume execution, or I can hit this. Yeah? OK. So we've got our .NET code, we're running it client-side using WebAssembly, and we're also debugging it client-side using client-side debugging tools, which is a pretty sweet user experience. OK, so that is going to be all I have time to show you about this thing. But go and have a look at it yourself, try it out, and let us know if this sort of thing is of interest to you and how you would need it to work, like what kind of platforms you want to support, what sort of performance constraints you have, that sort of stuff. There's a question, but would it be OK if I took it after the talk? Thank you. Just because I'm trying to squeeze in every last moment of content into this talk. All right, so WebAssembly browser support. It's looking really, really good. Okay, so it's on by default in Chrome, Firefox, and Safari, and that's also the case for mobiles. I don't just mean desktop, even on Android and iOS, it's on by default in the current versions. Edge has also got a full implementation of it, but it's currently behind a feature flag. Again, I'm hoping that that thing is going to be turned on by default fairly soon. Okay. That's WebAssembly. Now, let's move on to the last two things that I want to talk about today. These are features that are not quite as well known. You might not have heard of them, but they do give you possibilities to do some cool new things that you will not have done before. Okay, it sounds really boring, but it's not that bad, honestly. Credential management, okay? What's that about? Well, it's about one of the many, many things that we've had to struggle with as web developers since the very beginning, and this is user logins and registration and sign in and change my password and reset my password and all this kind of stuff that's utterly, utterly boring, but you have to just keep doing it over and over. Credential management gives you a new set of APIs in the browser that allows the browser to do stuff that's actually useful for you. For example, it allows the browser to store credentials on for a given user. It allows the user to pick which of different accounts they want to use for a given site. And it even does some cool things like being able to synchronize login state across a user's devices. So if the user registers for your site on their laptop and then they open their phone and go to the same page, then they're just logged in automatically with the same account, and they didn't have to do anything to make that happen. Okay, so that's credential management. And I want to show it to you. And to show it to you, I'm going to have to demonstrate a little bit of a business startup idea that I've been working on in my spare time, which I'm hoping is going to make me extremely rich indeed. And it's a startup called CEO Portal. The idea with CEO Portal is that the very powerful titans of industry, the CEOs of multinational corporations, will be able to create an account on CEO Portal, and they'll be able to use it to do all the kind of day-to-day business activities that they use to add such value to our wonderful economy at the moment. Okay? So I'm going to start by running that in the browser right now. So I will set that as my startup project, and I will get that running. And when that comes up, you'll see we've got some quality corporate web design there, which CEOs love, as far as I understand. Okay? And when a CEO sees that, they're going to be like, yes, this looks like just the sort of thing I need. But is it secure? Can I trust them with my username and password? So I'm going to have a really bulletproof, modern login and authentication system. And that's what I'm doing using the Credential Management API. So let me show you some of the code that is running when this page starts up. Okay, when it starts up, let's just have a few breakpoints here, here, and here, and then I'll hit reload. And you'll see what I'm doing is, the first thing I'm doing is I'm checking whether this browser supports the Credential Management API, and it does. So we move on to the next stage of saying, right then, browser, using Credential API, I want you to get me whatever credentials are stored for this current user. And the browser says, sure thing, here they are, undefined. This user does not have a stored account on this website. And so you will then have some logic to display your application in a logged out state. And that's what I'm doing right now. Anyway, when the CEO sees this, they're obviously going to be convinced of the benefits, so they will want to register an account. And I've got a little bit more code that handles that down here, and I want to show you what happens. So the user comes along, they clicks on register, and they're going to create an account. So let's have Steve, and I'll have a nice secure password there. I'll hit register, and it's going to hit this breakpoint down here. Okay, so what's that going to do? Well, it's going to start by constructing a new password credential object. There are various types of credentials that exist to do with like federated logins and stuff like that, but the simplest one is a password credential, which is just a username and password pair. And I'm saying I want to populate it by getting stuff out of an HTML form. That's this form element. And the browser can use some conventions to get the username and password out of there. And so now I've got this credential object, and you'll see it's got my username and my password that I use for everything, don't hack me. And next, after that, I'm going to tell the browser that I want to store these credentials. So Navigator credentials store, okay? And when that line of code runs, the browser will pop up a little bit of UI to say, hey, do you want me to store this password for you? Now, CEOs are very busy. They do not read dialogues. So they're just going to click on whatever button is most visually obvious. And that is this button here because it's blue. So obviously, the user is going to click on this button, and the browser is going to have stored the credentials for that user. And now I've got some logic that will switch the application into a signed-in mode. Okay? So this is what it looks like when you're signed in. It says, welcome, here's your username. Here are some cool things that you might want to do today. Okay? So that looks good. But what happens when the user comes back later? Are they going to have to sign in again? Well, let's see what happens when I hit reload. When I hit reload this time, we get to please get whatever credentials are stored for this user. And this time, instead of getting undefined, you'll see I've got the password credential object from before. So I know the username and I know the password. And now on the client, I can display the application in a logged in mode. And I can also store that password credential in my application state so that whenever I make any calls to the backend server, it will get the relevant data and it can authenticate the user properly. Okay, so let's just remove these breakpoints, and you will see that the application shows up in a logged-in state. And in fact, every time I hit reload, it's going to come up immediately in a logged-in state. And if you look carefully up in the top right, you'll see the browser even knows that we're signing them in because it sees me using these APIs, and the user knows which account they've been signed in as. Okay, that's good. But other things you can do are, for example, having multiple accounts. So if I sign out and then I sign in, oh no, I don't want to sign in. I want to, let's start again. I want to register a new account, okay? And then I want to, what am I doing? Okay, right, very good. I'm going to sign out, then I'm going to register a new account. This time I'm going to be Bert, and I'll register that. Continue, save the user account, there we go. Okay, and now I can sign out, I can sign in, and the browser will prompt me, which of your saved accounts do you want to use? So I can be Bert today, welcome Bert. And then I can sign out, sign in, and I can be Steve, welcome Steve. All right, so the user's got a nice quick way of switching between different accounts that they've got. And like I said, the browser can even deal with synchronizing login state across the user's different devices. Now, as for how that works, that's not your problem unless you work for Google or for Apple or for anyone else that makes a mobile operating system. Because it's just going to somehow do that synchronization for you in the background, and you can just don't have to care. It's just going to happen. Okay, so that's credential management. The last thing that I want to show you, after I've talked about this, credential management, current browser support is not looking great at the moment, I'm afraid. So like I've just shown you, Chrome has got this thing turned on by default. Safari has committed to doing it. It's not completely surprising that Google and Apple are the ones most interested in pushing this because of their mobile operating systems. Edge and Firefox are not yet completely convinced. They said they're considering doing this, but it is on a standards track, so you would hope that they will eventually do it and we'll have a universal feature there. Okay? So that's credential management. And the last thing that I want to show you is another valuable feature, and that is payment requests. Okay? So if there is one thing that web developers love more than anything else, it's getting money out of people who use their websites. And traditionally, that has been a very difficult and messy process because you have to ask the user to type in their credit card number and their shipping details and like go through a 25-step process, and the users are like, oh, I can't be bothered to type this out, and then they don't even complete the purchase flows, and you don't get their money. And morally speaking, that is a crime because you deserve the money that those people would have. And that is what payment requests are going to help us with. Now, you know if you do in-app purchases on a mobile app, you don't have to type out your credit card number, right? All you have to do is press a fingerprint or Face ID or something like that. That's what payment requests allows you to do on a web page. It makes payment requests into a native feature where the browser can show you whatever kind of UI makes sense for the device that the user is on, and then it can give you whatever payment details the user has stored for their credit cards and their delivery addresses and that sort of thing, and hopefully then the user will actually complete the purchase flow more reliably. Right, so let me show you that. And this is how I'm planning to monetize CEO Portal, actually. My goal is that when users come along, they'll see all these things and they'll think, oh yes, I love doing all these things, especially changing product goals. But today, the thing that I'm going to do, because I really love it, is review some key financials. So they're going to click on Review Key Financials, and what's going to happen is this. That's a premium feature. If you want that, you're going to have to unlock it, which is 50 gems. And the user will think, oh, that's cool, that's fine. Oh, no, look at this. I've got 0 gems. I'm going to have to get some more gems. So they'll click on Get More Gems, and that will take them into the gem store, okay? Yeah? All right. And then the CEO will think, well, how many gems shall I buy? Well, I don't know why, but subconsciously, I feel my attention is being drawn to this 50 million gems option. And so they're obviously going to click that button. But when they click that button, what's going to happen? Well, let's freeze time for a moment, and we'll think about what code is going to run. Okay, now I'm going to show you the code that I've implemented when they click on that Buy Gems button. And it's going to call this method here, Buy Gems. And what does that do? Well, firstly, it's going to compute the prices. And you need to understand this about payment requests. They do not have a concept of things like tax and delivery charges and stuff. It's completely up to you to implement that sort of stuff. So here, I've got my shipping amount. I've got a mandatory 20% tip, which I think is reasonable, and I think that will catch on. And then I'm computing the total price. Okay? And once I've done that, I can construct a new payment request object. And there are lots of different ways you can configure a payment request. In this case, I'm saying I'm going to accept these 2 different types of credit cards, but you could also accept things like Google Play or Bitcoin ferrets or whatever other thing you think that the user's device might support. As long as it supports it and you say you accept it, then it's going to prompt them with that option. And then we can also specify what line items we want it to display. So I've got these 2 items here for the gems and the shipping. And then I'm going to display the grand total, shipping stuff. And I'm saying I also want to collect a delivery address from this user, as if that makes any sense in this case. And then I'm going to display that payment request. And the browser will pop up whatever kind of native UI it thinks makes sense in this case. And the user will hopefully confirm the purchase. And when they do, we'll get the success callback, and it will pass all the payment information to you. Or if they cancel it, then it's going to call the error callback. Okay? So let's go back, we'll unfreeze time, and we'll click the button, and hopefully we'll get some money out of that juicy corporate credit card, okay? So I'm going to click it, and what happens is our code runs, and the browser chooses to display this particular type of native UI. And it's going to give the order summary, and we can go in and we can see all that stuff, and that looks reasonable. We can pick a shipping address, we can pick a shipping method, as if there's any other method for virtual gems. And then we will click on which credit card we want to have. Let's have this one here. And then finally, I can click on the pay button, and that is going to move the user on to the next step. In the case of Chrome, it chooses to ask the user to confirm by typing in their CVC number. So I'll type that in. Other browsers and other devices might choose to use a different UX flow, depending on what makes sense. But in this case, this is what it does. And I click on Confirm, and that's going to send the payment request data back to my application where I can collect all that sort of stuff. Now, it's not automatically transferring money. It's still up to you to pass all this data through your payment processor or whatever kind of approach you want to use to actually get the money. It's just automating the process of collecting the information from the user. Okay, so that is that. That's payment requests. As for browser support, well, I've just shown you it working in Chrome. Good news for Edge, that's already shipped and on by default there. It looks different. When you click on Pay in Edge, it brings up the Microsoft Wallet, which is a different way of selecting your saved payment methods. But it's there and it works. The other 2 browsers are also doing it too. So Safari has already got it implemented in their technical previews, and Firefox has said at least that they're doing it, even though it's not shipped. Yeah. Right, that's payment requests. And that's all the stuff that we're going to have time to talk about today. I just want to leave you imagining what your next mobile or desktop web application might look like. you might be able to do some cool things that you've never done before. For example, you could use service workers to make your application work offline. You could also use service workers to be able to receive updates from the server or push changes back to the server, even when the user is not on your web page. That's pretty cool. You could also implement your client-side code, not in JavaScript or TypeScript or a related language, but in something completely different, compiled to WebAssembly. You could also use the Credential Management API so that users are automatically have their login states synchronized across all their different devices. And you could even get money out of them with a really clean user experience, as simple as a fingerprint or Face ID or whatever it is that their device chooses to do. And none of these things are things that you would have done a year ago because it would have been too much of a mess and the technology wasn't stable enough. But in the coming months, this sort of thing is becoming entirely practical. So a lot of cool new toys for us as web developers. So there we go. That's all I've got time for today. Now, if you've got any questions, I know there was one. I will be around for a little bit, so please come and chat to me. Also, please remember to evaluate the session on your way out. And other than that, just have a really good last day of your conference.